All right, so if we take a look here at the top of the page, we kind of have this diagram here that has a lot of arrows going lots of ways. And we've got a lot of units that we would actually probably recognize, right? So mass, for sure, we should be able to recognize that that unit is going to be in grams, okay? And moles, we might be a little shaky on moles, but we should feel pretty confident in moles because we learned a lot about moles yesterday when we talked about molar mass, okay? Number of particles, we're not going to get this section of this little diagram today. We'll get there tomorrow. I like to think about these conversions that we're going to learn today as being one-step conversions, okay? We are going to learn two types of one-step conversion. So we're going to learn the first type today, this mass to mole, mole to mass. And then tomorrow we'll learn the other type of one-step conversion, okay? On Friday, we'll get to our two-step conversion, and that's the maximum. We're not going past two-step conversions, okay? So if you think back to our conversation about dimensional analysis, sometimes you were using like 4 conversion factors in those problems, okay? The maximum number of conversion factors that we're ever going to use now is 2, all right? So it's not going to be as tricky as setting a really long conversion factor like we were doing last week for practice, okay? All right, so let's read this kind of sentence at the top here to introduce this to ourselves. It says, the molar mass of a compound can be used as a conversion factor to relate an amount in moles to a mass in grams or to the number of particles in a substance, okay? So basically, in order to go from mass to moles or moles to mass, the conversion factor that we're going to have to use here is molar mass. All right, can anybody tell me what the unit for molar mass is? You probably wrote it 16 times yesterday.
Grams per mole.
Grams per mole, exactly. So grams per mole. Now what that means, guys, is that the grams of a substance okay, so let's just say, let's use an example. Let's say carbon, okay? So carbon's mass on the periodic table, 12.0107 grams of carbon is equal to 1 mole of carbon. All right, that's what our molar mass really tells us. We can use these numbers here, our mass from our periodic table, and that being equivalent to 1 mole, we are going to use this now as a conversion factor, okay? I want to kind of press you a little bit further here before we get started. Would it be true then if I were to find, let's say, the molar mass of a compound? Let's say we were to find the molar mass of CH4. It's going to be right around 16. Let me calculate it real quick. It'll be about 16.04. So if I have 16.04 grams of CH4, what is that equal to in terms of moles of CH4? Anybody want to take a guess? What? It's equal to 1 mole. Yes, exactly, Chris. Very good. So guys, the molar mass of a compound is also going to be equal to 1 mole of that compound, okay? It is this same idea that we have with the element that we just talked about for carbon, but that is applicable to any substance that you're working with, right? Think back to yesterday's definition of molar mass. It is the mass of 1 mole of a substance. And that's why we use that general substance word there, because we're going to talk about compounds. We might be dealing with elements, And those that fact that our molar mass is equal to 1 mole of that substance, that is true for anything that you're dealing with, whether it be an element, a compound, an atom, or a molecule. Okay, let's see how this is going to kind of roll into our actual problems today. Okay, all right, so let's start with example 1, friends. Let's read it, and then we're going to start to figure out how to set this up. All right. It asks us to calculate the mass in grams of 2.00 moles of sodium. So the first thing that I want to think about here is this number has 3 sig figs. What that tells me, if I'm only doing multiplication and division, which I'm going to be doing, that tells me that my answer needs to have 3 sig figs. Okay, so significant figures took a lot out of us, right? It was a little bit challenging, but now that we're actually going to apply them to problems, it's very straightforward. Okay, all right, so we're given 2.00 moles of sodium. Sodium symbol on the periodic table is Na, and it wants us to calculate the mass. Okay, so I'm going to treat this like any other dimensional analysis problem, and I'm going to start with what I'm given, and I'm going to put it over 1. All right, so let's start it off. We're going to start with 2.00 moles Na sodium is the symbol for sodium, over 1. I'm going to draw my multiplication symbol, and I'm going to draw my line. Now, if I'm calling back to last week when we did dimensional analysis, what unit needs to go in the denominator here? What unit needs to go down there? Moles. Is that what you said? He said, Christopher says grams. He's not sure if he's right. Anybody else have an idea? All right, so how about we think about the need to cancel out our units, okay? So if I have moles of Na up top here, that's what I'm starting with, the same unit needs to go in the denominator here. So I need the moles of Na in the denominator. Now, Chris is not entirely wrong. We are going to use grams here, okay? Grams of Na are going to go on the top. We're searching for grams, right? It wants us to find grams, okay? So now I have this set up. What does this look like? I've got grams and moles in a conversion factor. This should trigger something in your memory and have you think of molar mass, okay? So how do I find the molar mass, those grams of Na? Where do I look? Periodic table. Okay, so I'm going to find Na. Na is sodium. It's number 11 on your periodic table. Because I am using the molar mass of sodium as a final calculated molar mass here in this problem, I am able to round to 2 decimal places. So we can round that molar mass of sodium to 22.99 grams of Na. Okay, now you tell me, what is 22.99 grams of sodium equal to in terms of moles of sodium? How many moles is 22.99 grams of sodium equal to? Think about this. 1 mole. Yes, exactly. All right, we have set this problem up. We are ready to calculate, okay? So in my calculator, what I am typing in is 2.00 times 22.99. Knowing that I can only have 3 significant figures in my answer, I believe I get 45.98. Let me confirm. 45.98 is what I get. Because I can only have 3 sig figs, though, I'm going to have to do a little bit of rounding here. So I'm going to round this to 46.0. And what is my unit going to be on my final answer? I've canceled out the moles and the moles, so the only unit that I'm left with is grams of Na. So that is my unit on my final answer. Make note of the fact that you must include the symbol for the element, right? Or the formula for the compound. You have to include that in your final answer. That's part of the unit. It's not complete without that Na there to signify that you've calculated this for sodium. All right, guys, how do we feel about this process? Any questions or concerns right off the bat? Okay. All right, before we deal with our second question, I want us to jump to our periodic table. I have my copy right here in Notability. And anywhere on your periodic table, I want you to go ahead and add in this note here, and that's about the diatomic gases. If you don't have a copy of the periodic table saved in Notability, you can do that now, or you can just write this in a note on your iPad that you can reference. Okay. So what we kind of want to learn about here is, or are rather, some of our diatomic gases. Now, what this means, diatomic really refers to two. All right, and basically these elements here are elements that exist naturally in this molecule of two of the atoms bonded together, and they exist in a gaseous state naturally. Okay, we've actually alluded to one of these diatomic gases before. We've alluded to the oxygen, the O2. All right, so that air that we're breathing in consists of O2, oxygen gas. It does not consist of just oxygen, single oxygen atoms together. Okay, so we also have a couple of other elements that fall into this diatomic gases category: hydrogen, nitrogen, fluorine, iodine, and bromine. Now these, we're not going to use them very often right now. We will begin to use them a lot though in Unit 7. Okay, so we want to be able to recognize these as your diatomic gases, and that's why we kind of add them to our periodic table. It's just like another reference for us. All right, does everybody have that jotted down? Anybody need more time with those? All right, so let's jump back to our worksheet, and let's take a look at example number 2. All right, example number 2 says calculate the number of moles in 64.0 grams of oxygen molecules. All right, so clearly we just talked about diatomic gases for a reason. When this tells you that you're dealing with oxygen molecules, you're not just dealing with O, you are dealing with O2. You're dealing with oxygen gas molecules, okay? That's not going to, terribly impact our problem, but it will impact a piece of our problem. All right, so we're going to start this one the same way we started our other one. Let's first identify how many sig figs our number has, or given. It has 3 sig figs, so I'm going to be looking for 3 sig figs in my final answer. All right, let's start by setting this up the same way we set up our other problems in all of our dimensional analysis problems, by starting with our given and putting it over 1. All right, so I've got 64 grams of O2 over 1. I'm going to set up my multiplication sign, and I'm going to draw my line. Again, I'm going to think about dimensional analysis in the units. So if I have grams of O2 on the top here, that's what I'm beginning with. That's telling me I need grams of O2 in the denominator here. I'm trying to calculate the number of moles, okay? Because that's what I'm trying to find. That is what is going to go on top in our conversion factor, moles of O2. What I hope you recognize here is, again, we have grams and moles in our conversion factor. This time moles are in the numerator and grams are in the denominator, but we are still going to call upon our molar mass as our conversion factor here. Okay, you do need to take one extra step in this problem, because we have to calculate the molar mass of O2. We're not just dealing with one element now like we were in the first problem with just sodium. First, before we can continue, we have to calculate the molar mass of O2. It shouldn't take us too long. We're going to multiply 2 times the mass of oxygen from the periodic table, which is 15.9994. When I solve that, I get 31.9988. I need to round 2 decimal places, so I am going to have to round a bit to 32.00 grams per mole as the molar mass. All right, friends, where in my conversion factor does this 32.00 go? Does it go with the moles in the top, or does it go with the grams in the denominator?
The top.
Okay, so I have a vote for the top and I have a vote for the denominator. So that 32.00 is going to go with the grams, wherever the grams might be. In this problem, the grams are in the bottom. So I'm going to write 32.00 grams of O2 in the denominator there. How many moles of O2 is equal to 32.00 grams of O2? 1, exactly. So I'm going to have 1 mole in the numerator. All right. We are ready to solve this problem, friends. In my calculator, I am multiplying across the top, and I am dividing by whatever's in the bottom. Because I'm multiplying across the top here, I'm just going to get 64.0. And then when I divide that by 32, I'm going to get 2 in my calculator. That does not have 3 sig figs. So how can we write that number with 3 sig figs? We can write it as 2.00. And my unit here, guys, is whatever's left here on the top. So it's going to be 2.00 moles of O2 as my final answer. How do we feel, guys? Questions or concerns so far? All right, I'm going to do 2 more problems with you, which means there's going to be 2 problems for you to do on your own, okay? So after having 4 practice problems done for you, I hope that it will be enough practice to help you, figure out the last 2 problems on your own, okay? Let's jump down. Let's go ahead and just do the first one under mass to moles, and then we'll go ahead and do one on the second page from moles to mass. All right, so this problem gives us 64.1 grams of aluminum, and the directions are here. It says calculate the number of moles. I'm going to go ahead and add that in here just so I don't lose track of it. We're trying to get to moles of aluminum. Aluminum is element number 13 on your periodic table. It's sort of on the right-hand side there. All right, so let's go ahead and start this off by writing what we're given over 1. With the units, we're never going to not have units here, guys. So we've got 64.1 grams of aluminum over 1. And then I'm going to go ahead and draw my line. I am thinking to myself, I have grams of aluminum up top here. So that tells me that I must have grams of aluminum in the denominator here. I'm looking for moles. That's what I'm trying to solve for. So I'm going to put moles of aluminum in the numerator. For my grams of aluminum, I'll look at the periodic table. Aluminum's mass is 26.981538. Because we're using this molar mass in our conversion factor, we can round to 2 decimal places. So I'll go ahead and round that to 26.98. I know that aluminum's molar mass, 26.98 grams is equal to 1 mole of aluminum. So I'm going to have 1 mole of aluminum in the numerator there. All right, I am ready to solve this out. In my calculator, I am multiplying across the top. So I'm going to be left with 64.1. And then I'm going to divide by the bottom, which is 26.98. I get a really long decimal there. So let's go back up to our given 64.1 that has 3 sig figs. So I know that my answer needs to have 3 sig figs. So when I see what I get in my calculator, I get 2.375833951. I'm going to do a little bit of rounding here, and I'm going to round it to 2.38. And my unit is moles of aluminum. That's what we were left with on the top there, friends. All right, our grams of aluminum canceled out, and we were left with the moles of aluminum on the top for the unit for our final answer. That's also what we're trying to solve for, okay? So that should indicate to you that you did this problem correctly when you end up with that unit that you wanted to find. Questions or concerns on anything in this problem? All right, guys, let's slide down to the, so you'll be responsible for this question number 2, the 50.0 grams of calcium chlorate. Okay, that'll be one that I do, that you guys do on your own. Okay, let's slide down to the moles to mass section. Let's go ahead and assign you guys number 1 on your own, and I'll go ahead and do number 2 under the moles to mass section with you, with the 9.37 times 10 to the negative third moles magnesium. We'll tackle this one together because it's in scientific notation, and sometimes that kind of throws people off a little bit. All right, let's read the problem. It says calculate the mass of each of the following amount of moles. So I'm given moles of magnesium, and I'm trying to go to grams of magnesium. Magnesium is Mg. It's element number 12 on your periodic table. All right, I'm going to go ahead and start with what I'm given over 1. Making sure to include units. I'm going to draw my multiplication symbol and then draw my line for my conversion factor. All right, because I'm starting with moles of Mg, I have moles of Mg at the top there. What that tells me is that I need moles of Mg in the denominator of my conversion factor because I'm trying to cancel out those units. All right, on top then has to be grams of Mg. I'm thinking molar mass. All right, so let's look to our periodic table. Magnesium's molar mass is 24.3050. I can round to 2 decimal places, so I'm going to round that to 24.31. And then I'm going to ask myself this question: how many moles of magnesium is equal to 24.31 grams of magnesium?
1.
And the answer is 1. Yes. Very good, Esma. Thank you. All right, I am ready to calculate here. I only have 1s in the denominator here, guys, so all I'm going to have to do is multiply across the top. When I multiply across the top, remember I am looking for, oops, we didn't identify it again, that's my bad. We are still looking for 3 sig figs. All right, why don't you guys go ahead and try and type that in, and then type into the chat what answer you get when you multiply across the top there. Okay, and Jimmy has written it in scientific notation. You are more than welcome to do that. You don't have to do that if you don't want to either. Okay, again, remember we're looking for 3 sig figs here. All right, once you get an answer, you can type it in. All right, we've got a 0.23. We've got scientific notation again, and then we've got 0.228. Very good, guys. So with 3 sig figs, we will report this as 0.228. Rewrite those. And the unit is grams of magnesium, okay? Again, if you would like to write that in scientific notation, you can, 2.28 times 10 to the negative first grams of magnesium. Either answer, guys, is totally acceptable, okay? Both of those answers have 3 sig figs. And let's confirm our units, right? We started with moles of magnesium on the top. They got canceled out with the moles of magnesium on the bottom. And so we were left with the unit of grams of magnesium on the top. All right, any questions or concerns on that problem there?